Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Rat Run 25 Mod Cons by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. F and P must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, share cells, cross themselves or each other, or pass through any thick maze walls. So that means any cell in the grid can only be visited at most once by any path. The paths cannot cross themselves or each other. They cannot share cells, and you cannot pass through thick maze walls. As well as moving orthogonally, they may move diagonally if there is a 2x2 space in which to do so, but they may never pass diagonally through a round wall spot on the corner of a cell. So I don't know which one's F and which one's P, but maybe we'll have F down here and P down here. If P were to go here, she cannot go diagonally through this rounded wall spot, because this is considered a wall spot. But say F were to go here, then she could go diagonally in any of these cells because there's no rounded wall spot for her to be blocked by going diagonally. So that's how these paths work. We have black courants, where if a black courant sits between two digits, then one is double the other. So these are normally known as black Kropke dots, but for the sake of this experiment, they are black courants which can be eaten by both F and P. So for example, say this were a 2 here, then this would have to be 1 or 4 to make sure that one is double the other, because there's a black dot between them. We have one-way doors, where F and P may only pass directly through a purple arrow if moving in the direction the arrow is pointing. An arrow always points to the smaller of the two digits it sits between. So, for example, you could have something like 6 and 5 here, and that would be valid. You could not have something like 6 and 7 here, because 6 is not greater than 7. And for the paths, like, for example, P cannot go this way, because she would be going the opposite direction that the arrow is pointing, which is not allowed. And that's how these one-way doors work, or greater than signs. We have motion sensors. Oops. It doesn't highlight all of them. Oh, wait, it highlighted that one. That's weird. I didn't highlight that. I don't understand. Anyways, these are 3 motion no, those are video cameras. These are video cameras. These are motion sensors. So these pink digits on a pink motion sensor indicates the number of cells that are visited within the up to 9 cells immediately surrounding the sensor. The sensor itself is counted if visited. So, for example, say P were to go all crazy and then go, well, okay, say P were to go this way. Then this and F does not go in this direction. Then in that case, this motion sensor would have a value of 4. Because in the 3x3 box that is centered on the motion sensor, the number of cells visited by any of F or P is 4. So that's how motion sensors work. We have video cameras. where 3 video cameras, where the digit on the gray camera indicates the total sum of the digits in any visited cells that the camera lens points towards before a wall is reached, which blocks vision. So, if, say, f were to go something like this, to here, and p were to go something like this to here, this digit on the video camera must sum up all the digits that would be on the path. Obviously, that's going to be a problem. This video camera would have to sum all the digits on the paths that it sees here. So it would be the sum of these 3 digits. So say we had 2 here, 3 here, and 1 here, then this would have to be 6, because that's the sum of the digits that are along paths that it sees in the direction it points to. And then this would be 0, which obviously doesn't work. So that's obviously going to be something that's problematic there. And that's how video cameras work. And finally, we have a test constraint where in this experiment, both paths are valid modular lines, where any set of 3 consecutive digits along the path contain 1 digit from each of the groups 147, which is 1 mod 3, 258, which is 2 mod 3, or 369, which is 0 mod 3. So for example, on this set of 3 digits, since this is 1 and this is 1 mod 3, this is 0 mod 3, these would both have to be 2 mod 3. Then you could have something like 5 here and 5 here, or 2 here, or an 8 here. Any combination as long as 3 consecutive digits on the path contain 1 digit each from the groups, from the sets 1 mod 3, 2 mod 3, and 0 mod 3. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So the thing is, we need a path to, some path has to be here because, and it has to be 2. So in a path, you have to have at least 2 digits that are on that path. So this must have 2 digits at least. It cannot be the full 5. So if we go this way, it has to be 3 digits here. Or P could never even go that way, right? So P does actually have to exit out here or this way. So she is going one of those directions. She could go that way. F is going either this way or this way. We don't know which. So these pink cells on the edge are 1 through 6. Okay. For 2 unique digits, for 2 digits on a that are next to a black crop key dot, they cannot have 5, 7, or 9. That's 1, 2, 3, 4, 6, and 8 there. This digit is next to 2 unique digits on. Sorry, it's in a 1-to-2 ratio with 2 unique digits, so this must be 2 and 4. Which means these have to be, if this is 2, this is 1, 4 as a pair. If this is 4, this is 2, 8 as a pair. Either way, in this box, we are guaranteed 2 and 4 in one of those 3 boxes. These have to be 1, 2, 3, 4, 6, and 8. Obviously, this can't be 1 because that's not greater than any digit. This digit must be greater than 2 digits specifically. So this cannot be 2, this can't be 8. This digit must be less than this, which is 8 at most, so this is 1 through 7. Where is 9 in this box then? Can't be here because that would be less than another digit, so 9 has to be one of these two digits here. There must be at least 2 digits on the path here. There's at least 2 digits on the path here. There's at least 2 digits on the path here, but that, well, does that make sense? I don't really know. Anyways, this is guaranteed to have at least 2 digits that are on the path. So this is not 1. It could be 2, at least. Can it ever be 6? No. If it tries to go 6, it would have to go all the way around here. And then it would not be able to go to a cupcake because it would be... Can it be 5? Yes, it could be 5 going like that. That is possible. So this could be 5. We need... F or P is going to have to get to the cupcake here. So this is at least 2. It could be all 6. That's possible. Okay, so this can never be 1, because 1 would be in a 1 to 2 ratio with 2. To get to this cupcake must either go that way, or this way, or this way. How does this work? If P does not go this direction, that means she has to exit out this way. And the only way this can get multiple paths is F has to go essentially something like this, right? Which means it has to go through here, then here, then here. So that is potentially possible. I'm gonna pause. I need to go to the bathroom right now. I'll be right back. Okay, and we're back. Let's continue. If we were to go this way, how would that work? So if P were to go this way, she would immediately have to cut out here because this cell would be the sum of the digits on the path. And so then she would have to go here, and she could never go back here. So she would be forced to go this way. But these 3 digits would either be 1, 2, and 4, or 4, 2, and 1, or 2, 4, and 8, and 8, 4, and 2. And these 2 digits, 1 and 4, would be in the same set, and there would be 3 apart from each other, or not 3 apart from each other. They would be in a set of 3 with each other, which is not valid to be on the path. So F cannot, or P cannot go this way. P has to go this way then. So P must exit out this way. So then P has to go, she cannot go this way because again, she would be forced to go here because right now this is sum of 3 digits at most. She can't go back on this path. She has to be forced to go this way. And these 2 digits are the same modulo, whether they're 1, 4 or whether they're 2, 8, which is not allowed in a set of 3 digits. So she has to go this way. She could go around like that. That is possible. Or she goes straight through. So she has to go that way. We don't know which. She has to go this way. Hmm. So one thing we know then is these are not... She could go through here. She just cannot go this way. So this is not valid to be on a path. Obviously, this is not valid to be on a path. This is not valid to be on a path. And this is not valid to be on a path. You cannot go through here. That would be too many digits on this path. So none of these are valid to be path. You could do something like that. That is potentially possible. But the problem is, so say you were to do that. If you were to do that, the problem is either F has to go this way to get to that cupcake, or F has to go this way to go back through this way. So I don't think you can ever go through this cell. If you try to go through the cell, it has to be, it would be 4 that way, or 3 this way. But then the problem is going 3 this way. How is that going to work? So therefore, this is always on the path, on one of the paths. And you could do something like that. Or you could do all 3 there. No, you cannot do all 3. If you go all 3, then you have to go through that way again, which is problematic. So this must be going that way, then going here. So this has to go boom, boom here to basically go through. You can't go through all 3 of these, as we said. So these are not on the path. This is definitely a path going this way. We don't know if it ends there. Cannot go this way because that's 4 digits. So then has to go exit out this way. So it must exit out here and then here. So this is valid. This is not on the path. Could go here, could go here. Diagonal, we don't know. Same with this. This one must end up at the cupcake. Okay. This one must go through somewhere here. It cannot go through here. It could go through here, though. So P could actually go this route. So this is guaranteed to be one of these. So it's either 8, 4, 4, 2. So this is 1 mod 3 and 2 mod 3. So this must be 0 mod 3, and it can only be 3 and 6 to add up with that. So this is 1, 2, 4, 5. It cannot be 7 or 8, because that would add up to 10, at least here. So this could be 4 with 1 and 3. 2 and 3, adding up to 5. 4 and 3 adding up to 7. 5 and 3 adding up to 8. 1, 6 adding up to 7. 2, 6 adding up to 8. And those are the only possibilities. Therefore, this is 0 mod 3 here. It's 3, 6, and 9. We know either F goes through here to get to this cupcake, or F goes through here, or, well, it could go either way. F has to go through one of these two to get to either here or to get to this cupcake. So that means this must be 6 through 9 here to add up with 3 unique digits. could technically go this way, right? Straight 3 straight through. And then this would add up to something. Or it could go this way through here. This goes through here. It can go that way then to go through there. We don't know. Interesting. P, I guess she could go through this route. That is possible to get to this cupcake. Can P, well, P could go this way, and F could go that way to go back there. Oh, this can't be 2 or 4. It's guaranteed to be 1 or 5 here. Interesting. Ah, that doesn't work. Or, yeah. That doesn't work. If this is 1, because we can't have 2 and 4 remaining in the box. This can't be 2 or 4. If this is 1, that would mean this has to be another 1 mod 3, which would have to be 4, but then this would be 4, 2, and that would force that to be 1 there, which is impossible. So this cannot be 1. This is 5. It must be with 3 to add up to 8 there. This digit then cannot be 2, 4, or 3. If it's 6, this already adds up to greater than 9, so this has to be 1. So this is 1 here, which means this is 1, 5 with another digit, which it would be 2 and 3, adding up to 8 or 9. So this is 1, which means this is 4 here. So this has to be 4, and this becomes 2 and 8 as a pair. Remaining digits then add up to, or must be 6, 7, and 9. This is 8. 1 and 4, eliminate 1 and 4 here. So this cannot be, if this were 2, it would have to be 1 and 4 there, so this can't be 2, this can't be 8. Interesting. That means this digit is 2 mod 3, so this is 2, 5, or 8. We need another 0 mod 3. Not sure where. P can only go, okay, so then these, let's make these gray. 5, 2 mod 3s will make yellow. So these are yellow. 1 mod 3s will make red. So these are red. And 0 mod 3s will make blue. This is 2, 3, 6, or 8. Okay. Oh, this can't be 8 because of 8 in the row. Hmm. These have to be different sets, obviously. And that's going to be, oh, so this cannot be 3, 6. Right? If it goes this way, these are the same set, so these must be different sets. If it goes this way, these are different sets, so they cannot be 3 and 6. So it's either 4 with 2 or 4 with 2 and 8 or 1 with 2. This is a 1 mod 3. This is interesting, a yellow, a 2 mod 3. We also have a 2-8 pair in column 8, which eliminates 2 and 8 in the rest of the column. That leaves the remaining digits as 3, 5, 6, 7, 9. And 9 cannot be here because it's less than another digit. This must be greater than that digit, so this is 4 through 9. This cannot be 1 or 4 because this would be the same set. So this is either yellow or blue here. Because this can't be 1 or 4, this can no longer be 2 or 8. We don't know if it goes through, if F goes through this route. Sorry, P goes through this route. If she does, she could go this way, though. That's perfectly fine. If she goes this route, this would have to be 7. So this would be 3 or 6. And this would have to be 6 or 9. Either way, she's going this way. She would be, I guess she could be yellow than red. Never mind. Okay. I think either way. Okay, so if she goes this way, the problem is this can't. If it's 3 and 6 here, that's 3 and 6 there. So that would have to be blue and blue. If this is 2 and 8, which she's going to, this is 1 and 4, and that's red, and you can't have a set of 3 consecutive digits on this line be all red. So she has to go this route. So she has to go this way, which means this is not red, this is blue or yellow. So this has to be 2, 3, 5, 6, 8, and 9, and this is greater than this. This must be red. So this is red, and it's 1, 4, or 7. Okay. This has 1 digit, so this is not, well, she could go on that path. Or she could exit out, and this could be just 1. That is possible. What happens if she goes this way? It would have to be that she can't go this way. If she goes this way, one of them would have to be blue, which would be 0 mod 3, and that would be in a 1 to 2 ratio only with 6, which is also 0 mod 3. So she cannot go this way. She has to go this way. So then she must go back here. These are the same set, so these must both be blue. So these are both blue, which means this can't be blue. This is yellow. So she cannot be going this route because this must be yellow. This has to be red. This would be yellow, and these would both be blue. And then we'd have 3 blues here. So no 3 and 6 here because it's a 3, 6 pair. Sorry. It must be the same set, which eliminates 3, 6 in the rest of the box. No 5 or 9 here. This is 2 or 8. No 3, 6 here. No 3, 6 here. No 3, 6 here. Which means that can't be 3, 6. This can't be 3, 6. And that can't be 3, 6. Whereas 9, then, in box 2, it must be here. That means 9 cannot be here. This must be going red, blue, yellow. So this has to go this way, and this must be a 9 as a blue. So she has to go this way. So blue, yellow, red, blue, yellow, red, blue. She cannot be going this route because this is red, blue, yellow instead of blue, red, yellow, red. So this must be F coming from this angle. So P has to eventually get to here. She goes here. This is yellow. And so it's 2 or 5, but it must be 5 because we already have 3 cells that are sharing that edge. So this is 5, which eliminates 5 here. One of these is 7. So it has to go this route. Cannot go this way because she's stuck at a door, so she has to go this way. So then this is red, blue, yellow, red, blue, yellow, this is 1, 4, or 7. We're guaranteed a 4 here because it's either 4, 8, ratio, or 2, 4. So this cannot be 4 here. We're guaranteed we don't know about 2 or 4 there. This is 3 or 6 or 9. This is 1, 4, or 7. Remaining digits so she cannot go here then here. She can't go here then here because it has to be blue. So then she has to go around. So she must go red here. Then that follows with blue there. This is then 3 and 6. She can't go that way because they're both 3 and 6s, which makes that a 9. So she cannot go this way. So she has to go around here. So that's blue, red. Sorry, blue, yellow, red, blue, yellow, and then red. And she can go that way or that way. We're not sure. So this has to be 8, which makes that a 4. 8 can't be here. This is 2, which is greater than 1. This can't be 1 or 2. It's 7. This can't be 1 or 2. It's 4. 4 is in a 1 to 2 ratio with 2 or 8. If she goes this way, she would have to go there. And the problem is you'd have 2 mod 3s in the same 3 set. So she has to go this way. So then she goes that way. That's red. We have blue here. That means she cannot go this way because it would have to be, wait. Yellow, red, blue does work this way. Never mind. She could go this way. This cannot be 3. Because it sees at least 6. So this has to be 6 then. Which means then this is 3. Well, what does that mean? That means that P cannot go this way. P does have to go this way. So then we have yellow here. That means F has to go through this route. So F has to go here. We don't know what color. It cannot go here. So none of these can be touched. So these are not valid. That means she has to go this route. So these are guaranteed. This is guaranteed, and this is guaranteed. So cannot go here. This is not blue. One of these is blue. We have red, yellow, and red, yellow, and blue all in the set, which means we are missing, sorry, red, yellow, and blue, which means we're missing a yellow. So this has to be yellow here. So this is 2 or 8, which means this must be red here. So this is red, which means 3 away is red there. So that's going that path. Let's make this red path. This is blue and yellow as a pair. No 9 here, no 7 here, no 7 here. So none of these can be paths. This is 5 or 8. This is not a path. These are not, this is not a path. This is yellow. She cannot go here than here. So this is not a path. We have yellow here, which means she must go red and then blue. So she could go red, blue here, and then yellow. Or red, blue here, and then yellow. We don't know. 6 eliminates 6 here. This is 7, 9 as a pair. This can't be 7 or 9. It's 6 there. We don't know about this. This has to go this way. And then this way. So this is 2 or 3. Which means she cannot go 1, 2, 3. So she has to go diagonally there. And then here, and then this is red. So this is red here. Because 1, 5 plus 2 adds up to 8. 1, 5 plus 3 adds up to 9. Okay, this is 2, 5, or 8. This is 6 or 9. So she has to go, whoops, wrong color. Has to go there. Must be some combination of stuff here. Remaining digits actually in row, this has to be 1. In row 4 is 1, 3, and 5. We have 2 here, so this adds up to 9. It must be 1, 3, and 5. Or actually, it could be 2 digits. Never mind. It could be 2 digits. Cannot be 3 and 6, though. No 3 here. 9 eliminates 9 here, so that's 7, which makes that 9. Interesting. Huh. Remaining digits of column 9. We have 1, 2, 4, and 6. Okay. This can't be 4 because of 4 in the row. This is not 1, it's 4 or 7. This can't be 4, it's 1 or 7. This is 1, 4, or 7. 5 and 8 here. Remaining digits of row 2 have to be 3, 4, 5, 6, and 8. This cannot be 4 because it's not 1 mod 1 mod 3 can't be there. No 3 here because of 3 in the box. It's 5, 6, or 8. 1 and 2 eliminate 1 and 2 here, so it's 4 and 6. Where's 3? 3 can't be any of these digits. Can't be here, so 3 has to be here. Okay, 4 is 1. Where is 4 in row 2? Can't be here, can't be here, because these are non-red cells. These are filled out. 4 has to be one of these two, so this is not 4. It's 1 with 2, which makes this 8, which makes that 2. This can't be 2 anymore. No 2 here, that's 8, which means this can't be 8, that's 5. No 5 or 8 here, that's 6. So this is blue, which means this must be blue. So this cannot be blue. This is yellow, which is a 2. 1, 2, and 5 add up to 8. This is yellow. Cannot be 5 or 8, it's 2. 5 eliminates 5 here, so that's 3 and 5 here. So yellow cannot go this way. Yellow has to go this P has to go this path. And then it must go to a blue, so it has to go that way, then there. So this is red. Cannot be 7 because, or could be, no, cannot be 7 because 7 and 2 would add up to 9. So this has to be 1. So this is 1. No 1 here because of 1 in the row. This is 4, 7 as a pair. That eliminates 4 and 7 in the rest of the box. This can't be 7. It's 1. That means this can't be 1 or 2. It's 6, which makes this 4. No 4 or 6 here. It's 1, 2 as a pair. 6 eliminates 6 here. This becomes a 5, 7 pair. That leaves this digit as an 8. 2 eliminates 2 here, so it's 5, which means this can't be 5. That's 7, which makes that 5. So no more 3 and 5 remaining in column 8. This is 6, 7, 9 as a triplet. This can't be 2 because of the 1, 2 pair in the box. No 5, no 6, so this is 3, 4 as a pair. This can't be 2, 3, or 5. Must be 4. So that means F cannot go straight here unless we have P going all the way around here, which is, I guess, possible. This can't be 1 or 4. It's 7. This is 6 or 9. That means the remaining digits in, well, this 5 eliminates 5 here, so that's 8, which makes this 2. Remaining digits in row 5 are 5 and 7. That means this 6 eliminates 6 here, so that's 9. That means the remaining digit in box 4 is a 4. Remaining digits, this 9 eliminates 9 here, so that's 6. Remaining digits in row 6 are 3, 5, not 3, 5, and 9, 3, 7, and 9. So 9 cannot be here. This cannot be 3 digits here that are on the camera because we don't have 1, 2, 6 available. We don't have 1, 3, 5 available because she doesn't go that route. So it must be 1 and 8 somewhere here. So she cannot, so P cannot go all the way over here. So P also can't go here. So this is not on the camera. These are not on the camera. P has to go either here or here. 4 eliminates 4 here, so that's 3, which makes that 4. So she has to go 8. How does that work? That's problematic. Huh. Uh-oh. That's really bad. Oh. F has to go there. F has to go there. But okay, so then P has to go this route. Right, because F has to go to the 8 here, to one of these. So then P has to go this route. So P has to go here, because otherwise it's not going to work. So then this is red. This can't be the path. Red, this is blue, this is yellow, and this is red. So that forces this not to be 7. It's 6 and 9. That makes this 2, this 1, this 7. So these cannot, none of these two can be on the path because this sees 3 cells surrounding it. F has to go this route. So this is red. And then must go through there. So she's definitely going that route. Which means this is red to go this way. This must be yellow. One of these is 8. We don't know which. This is then blue. So this is 6 or 9. Cannot be 3 or 6 because of 3 or 6. 3 in the row and 6 in the column. So this is 9. Remaining digits. So these, she does not go through this path. This must be blue, which none 3, 6, and 9 cannot be here. So she must go there as blue. That's 4 already. So then she has to go back here as green or as yellow. Blue, red, yellow. This is not on the path because that's already 4. 4 eliminates 4 here, so that's 7. That's 4 there. 7 eliminates 7 here, so it's 5 and 7. That makes this 2, 8 as a pair. That leaves this as a 1. This cannot be 3 or 9. It's 6. The remaining digits of column 1 are 5 and 3. This can't be 5 because of 5 in the row, so this is 3. That's 5. 6 eliminates 6 here, so it's 9 and 6. We have yellow, red, yellow. So this has to have 1 red. This can't be 7 because of 7 in the column. So the red here has to be a 1. So it cannot be here. So this must come from there. Or must go to there. That's red as a 1. The yellow followed by blue. So 2 cannot be here because of 2 in the column, whereas 2 in column 4 it must be here. So that's 8, that's 2. Therefore, cannot go that direction, so must go here as blue. We have to get to the 8, so the 8 has to be here as yellow and is on the path for the camera. We have to go yellow, blue, red. And this has to be blue also. Remaining digits of row. So this has to be 3. That means this digit is a 7. So to connect to here, we need a blue. It can only go here. So this is blue and is 9. That leaves this not as 7 or 9. It's 3, which makes this 6, which makes that 3, which makes that 7. This can't be 3. It's 9. So must go this route. We need this digit then is a 5. You cannot go there. So must go this route. And this is red. Let's make sure we have blue, red, yellow, 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 blue, red. So obviously this is not on the path. This is not on the path. Actually, we can remove all of that. And this is blue, yellow, red, 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 blue, yellow, red. And that leaves this digit as a 6 and this digit as a 4. And the sum of 1 and 8 is 9. The sum of 2, 1, and 5 is 8. The sum of 3 and 5 is 8. This is 6 cells on the path around it. This is 5 cells on the path around it. This is 3 cells on the path around it. 4 here. 2 is greater than 1. 8 is greater than 3. 8 is greater than 7 and 4. 3 and 6 are at a 1 to 2 ratio, so are 1 and 2, so are 2 and 4, so are 4 and 8, so are 3 and 6, 2, 4, and 4, 8 here. And so this is a 4. Experiment completed successfully. Test date, February 11th, 1975. Cells visited, 47. Black currants eaten, 3. One-way doors used, 1. I have to concede that the cameras offer a fascinating glimpse of the maze from the rat's perspective. Watching the footage back, I almost felt I was in there with them. F was visibly intrigued by these new additions, pausing several times to look directly into the lens. P was characteristically, I can't say that word, characteristically unfazed and continues to move with a quiet assurance. Yet despite her laid-back approach, she has so far completed each Phase 3 test substantially quicker than her friend. Oh, wait. Which one's quick? I think then this one must be F, because this is the longer path, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this must have been F then, and this was P. Interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.